Hello, this is the first video for week 9 because we had week 8 as the midterm exam period, and this is also the third video for chapter 6, which is talking about the production theory. Okay, so since the last time we studied about the basic stuffs for production theory, so we talk about input and output and the production function mechanisms. So in this time, we study about the Isoquant curve, which is really similar to the indifference curve we already studied from the consumer choice theory. And we'll talk about the efficient point of production in the point of view of a single producer, which is really similar to the core lesson from the consumer choice theory. Okay, so the most important concept or most important theory last time we studied was the diminishing marginal returns, which means that when we talk about the output, we should always think about the input first, because the production is processed by a specific form of the mechanism, which is sometimes and commonly called a function. So we talk about the production function, and the function always has input and output. And we assumed that there are two common inputs, the labor and the capital. So if we put the first unit of labor or the capital, we get increasing amount of output or the production, the finished goods or services. And we expect our production function is increasing function, because as we put more input, labor and capital, then there is increasing amount of finished goods or services that will be traded in the market. Okay, but the law of diminishing marginal return told us that the marginal amount of increasing output will be decreasing as there is more input by unit. Okay, so for instance, if we hire our first worker, then there will be huge amount contribution from that worker to your final goods or services produced in your company. But if we hire 100 worker, then the marginal contribution of that single 100 worker will be relatively smaller than the contribution of the first worker. That's a kind of lesson we will remember for rest of our semester. And this time we will relax one more assumption about the production mechanism, which will introduce us to the long run production world. So we assume that there is only one input which is variable, and the other input, for instance the capital in the short term, is fixed as constant term. So we made our problem a little bit simpler. But now we relax that assumption, so we assume now that there are two inputs which are variable over time. So we can control the amount of labor and the capital at the same time. This makes the problem of production wholly different level, because we can control the combination of labor and capital to produce certain amount of output. When we fixed the amount of capital as constant, then everything was pretty simple. As we increase input, then output will be increased as well. But only one thing was important, which is the diminishing marginal returns, which means that the marginal amount of output contributed by the additional unit of input will be getting smaller and smaller as we put more input. But in the long run, there is no more fixed input. The old inputs are variable in the long run by definition. There is a little bit more complicated issue here, which is that if we fix specific amount of output here, then how many inputs and the other inputs can be substitute each other or can be complement each other. So let us think about, capital intensive good or the labor intensive good from your international trade basics. I assume that, you might not study about the international trade theory yet if you are just sophomore. So according to the international trade theory, by like the Heckscher-Ohlin model, you have capital and labor to produce any good or services, and every good has a characteristic, which is one of labor-intensive good or the capital-intensive good. The labor-intensive good is defined by a good which composed of labor and capital, but the labor part, percentage of labor, is larger than the percentage of capital inside that good, like some manufacturing industry. Capital intensive good means it has also labor and capital as an input, but the percentage of input as a capital is much larger than the percentage of input of labor inside that good. Maybe IT industry in Silicon Valley or the semiconductor from the Samsung Electronics, it is really capital intensive good. So, which means that the producer can determine one of each input can be put more or less relative to the other input. So they can control the ratio of those two inputs to produce a certain amount of output. So at this level, the intermediate microeconomics, we assume that we can control the ratio of those two inputs freely at the beginning of the production level. Okay. So we're going to introduce one really important definition, which is called the Isoquant. So if you remember the indifference curve and the shape of indifference curve, it is exactly the same, but in the different dimension. In the production part, indifference curve was introduced in the consumer choice theory or the consumption part, but the Isoquant is introduced in the production sector. Okay, so how was the indifference curve was introduced at the first time? We assume that there is certain amount of happiness or certain amount of the utility, and there are two goods in the two-dimensional world, which will satisfy that level, specific level of happiness, right? So different indifference curve had the different level of happiness, different level of utility, right? The same in the production function or production world. If we have the certain amount of output, then we need certain amount of input to produce that amount of output, specific amount of labor and specific amount of capital. Okay, but the ratio of those two inputs can be varied to produce the same amount of output. So which is represented as the Q bar in equation number 7, which means that the output level is fixed as the Q bar. So it is constant term. But we can control L and K to produce that Q bar. Sometimes you increase L and decrease K, or sometimes you increase K and decrease L in order to produce the same amount of Q bar, right? So there are numerous possibilities of the combination between the L and K to produce the Q bar. That's the Isoquant definition. So this is the example. So you can see the number of 24. Okay, so this column represents the amount of labor input, and the row represents the amount of capital. So the combination of labor and capital is represented in this table. For instance, one labor and one capital can produce 10 amount of output, but two labors and one capital, that combination can produce 14 units of output. Okay, so you can find out the number of 24. The first column and the sixth row, the one labor and the six capitals, that combination can produce 24 units of output. But two labors and the three capitals can also 24 units of output. Also, the three labors and two capitals can produce 24 units of output. Lastly, 6 units of labor and 1 unit of capital can produce 24 units of output. So the same amount of output, which is Q bar from the previous page, but different combinations. So we have 4 different combinations between the L and K input. So they are all in the same isoquant curve. Okay. So in this graph, we have 3 different isoquant curves. And farther from the origin, like Q equals 35, means there is higher level of output combination than the other isoquant curve like Q equals 24 or the Q equals 14. Higher level of output is better for a producer, but it also means that they need more inputs. So for instance, we can compare isoquant curve of the Q equals 24 and the Q equals 14. And we can fix the level of capital at the 2. So we can compare point E and the point C. Okay, let's look at first the Q equals 14 isoquant curve. At the point of E, the combination of input is 2 units of capital and 1 unit of labor. So 1 unit of labor and 2 units of capitals can produce 14 units of output. But fixing the level of capital at 2, you can increase the level of labor from 1 to 3. So you can move from point E to point C with more inputs of labor with the same amount of capital. You can produce more, right? Like produce 24 units. So isoquant curve is increasing as they getting farther and farther from the origin. That's the first lesson from this graph. The other lesson from this graph can be obtained by comparing the points B and C. So they are the same isoquant curve because the point B and the point C are on the same line or same curve. Point A is as well. So let's compare point A, B, C, or D. They have different combinations of the labor, right? 6 units of capital, 1 unit of labor can produce 24 units of output, but also 6 units of labor and 1 unit of capital. You can also produce 24, the same unit of output. So different combinations are possible to produce the same unit of output. So there are numerous, almost infinite possibilities to produce the specific level of output. And you can connect all these infinite number of possibilities of combination. Then it is called the isoquant curve. Okay. So this is the second lesson from this graph. So everyone is clear about the isoquant curve. So as we already studied, the farther an isoquant is from the origin, the greater the level of output. The same properties with the indifference curve. And isoquant do not cross. It is also very similar to the indifference curve. And isoquant slope is downward. It is also the same property with the indifference curve. We prove the first property, but you can also prove the second and the third properties of isoquant curve by yourself because it's the same, exactly the same logic from the indifference curve. So they do not cross, and I don't think the isoquant curve can be thick. You mean being thick means in economics, right? And also isoquant curve always going downward. It makes sense only in this case, and you can also prove this one too. in remain for your practice problem. I got several feedbacks from the students. They did not want to reveal their names in the internet, and they argued that the midterm questions are something very difficult because they didn't study about that. They didn't study about that stuff, but they had that question, so it was impossible to solve. It is partly right, but partly wrong. We did not discuss about that specific type of question in the classroom or in this video. But you studied everything, every tools or every fundamentals to solve those questions. And economics is kind of study that you don't have to memorize anything. And that's the reason why we did our midterm with the open book test. It doesn't matter to open your book or close your book to solve some specific questions, because economics is study of application. It is study of creativity, and it is study about insight on some specific issue. So, and this is also economics course, so you should be prepared to encounter an unexpected situation coming in your exam. So you need to apply your knowledge to solve some specific question. And I believe you didn't have to have a lot of mathematical skills to solve every question. As I already told you in the previous video, which was spoken in Korean, the mathematical difficulties was not that hard. Most of questions were the linear, so you don't have to take calculus or take derivatives. Just one question was a little bit difficult to be taken derivatives, but it is really common form in the economics. So I was pretty sure that you were pretty familiar with those terms. But the result was pretty different from my expectation. But anyway, if you expected to see some common types of exam in my exam, you got pretty wrong direction, because this is university level, and you are not the freshman anymore, so you are not high school students anymore. So memorizing everything, memorizing textbook or memorizing what the teacher is talking about and writing everything from your brain to the white paper, it is not the university level exam. It is very low quality education training system, and I really hate that type of thing, because university is the place to research, not place to memorize. It is place to discuss and find a way to solve a social problem, but it is not the place to discuss about what you memorize things, discuss about what you repeat, what the teachers say to you. I don't think I'm a teacher or I'm a perfect professor, but I'm kind of a leader to guide you to where you have to study. Okay, so, and this is one of my perception in these days of coronavirus. Many students think this is not the actual semester because you do not go to the school. You watch a video when you wake up late in the afternoon, and you can definitely play the videos of professors, videos of courses while you playing games or while you texting messages to your friends or eating lunch. So many students, this is just my perception, many students do not concentrate on the video or concentrate on the contents that the professors provide online. But this is the actual semester, and it will be recorded on your transcript forever when you graduate this school. So the same class, and you have to put more effort to get the grade you want, which means that since you do not go to the school, there is no more resource you can get from the university because you are home alone. So you have to find out every possible resources by yourself on internet or asking friends or emailing professors. So it is harder to study. So you need to put more effort. You need to put more time to get the same achievement. Like this Isoquant curve, right? So there is less capital you can be provided from the university because you do not go to school. So you need to put more labor input by yourself to get the same production or same Isoquant level. But I don't see many students doing that these times. It is a little bit disappointing to me, but it is also very natural to me as well because there is no supervision on your life in these days, and you may think, okay, so I do not have to go to school, so I can just play the video, so I can get the attendance rate, and everyone gets the same situation, so I can play more games because I can have the more times for my leisure or something. But I don't think you are having more time for your leisure. I think you have more time to study in these days. Just my idea. After first look at your answer sheet from the midterm. And although we had another problem from the Itaewon Seoul, another pandemic, very bad situation of the coronavirus 19 pandemic from the Itaewon Club situation. But I believe we can meet in person if you want, if you have any question, or if you want to discuss about your study problem or any kinds of concerns about this course with me directly, but the email is not enough to you, then you can request me to meet with me to discuss about your problem, because the government policy was a little bit changed or a little bit relaxed, so we can meet in distance with the mask or something. Then we can spend time together to discuss about your problem when you come to my office sometimes. Okay. All right, so let's go back to the class. So these are two extreme cases of the isoquant curve shapes. We know that the isoquant should be downward sloping, but those two graphs are two extreme cases. The left-hand side, what is the relationship between good x and good y, or input x and input y? They are perfectly substitute each other, right? How about the right-hand side? Cereal and the boxes.
네. 근처에서 첫 번째로 찾은 곳은 세종리에 있는 양화정입니다. 이곳은 어떨까요?
별로야.
좋은 얘기는 아니네요.
네, 안녕. I hate the Siri system of iPhone. She never responds me correctly, and she sometimes responds me in the wrong time. So, terrible system. Right-hand side, the relationship between the input of box and the input of cereal, they are perfect complement each other, because without box we cannot buy cereal, and without cereal the box is empty, so it doesn't have any words in the market. So they may have the complementary relationship, and according to this textbook, it tells us that the cereal and the box are perfect complement each other. So the shape of The Isoquant curve is very similar to the perfect complement indifference curve. Okay. So Isoquant curve is between those two extremes. So it is semi-substitute each other or semi-complement each other. It is just between the perfect substitute and the perfect complement. So it is downward graph, but usually it is not linear, but it could be a linear, or it could be like this kinked version of perfect complement. So the common Isoquant curve is just between those two extremes. So they are partially substitutable. This is really difficult to pronunciate. So we're going to introduce one difficult mathematical definition. So it could be challenging to many students, but just take a deep breath and look at the equation carefully, then you can definitely understand this one. Marginal rate of technical substitution, MRTS. So MRTS means that how many units of capital can be replaced by the extra 1 unit of labor, while the output level is the same. So in order to produce the same output, the Q bar from the equation 7, then how many capital is needed, or how many capital is replaced by 1 unit of labor. So the MRTS is the marginal change of capital over marginal change of labor in mathematical term. And in mathematically, it is the slope of the Isoquant curve. So in extreme case of perfect substitute each other, there will be only one MRTS, right? Because it is linear. How about perfect complement? There is only one kinked point there, so the slope should be the infinite. So we cannot have a specific solution for the perfect complement case. And we have only one solution for perfect substitute case. And usually, in a common Isoquant curve, the slope of Isoquant curve can be buried over the point. So in each point, they will have the different slope, which means that they have the different MRTS. So MRTS means economically the specific substitutability between the two inputs. So in terms of labor, how many capitals can be replaced at each point? Okay. So this is the example. So MRTS can be buried over the point because Isoquant curve in this graph is not linear anymore. Okay, so from point A to point B, there is one more labor input was put in the production process, right? So there is increasing one more unit of labor. Then capital is decreased by the 6th unit, so -6 there. So the slope from A to B is -6, which means that from point A to point B, the quantity of output is the same, a 10, right? So in order to maintain 10 units of output, if you want to increase one more unit of labor, then you should decrease 6 units of capital to maintain that output. But from point B to C, there is also one more additional extra unit of labor input was increased from 3 to 4. Then the decreased amount of capital input was -3. So in this case, MRTS from point B to C is -3. So MRTS has been decreased by half, right? Which means that you don't need to sacrifice much capital from point B to C when you were from point A to point B. Okay, so the MRTS has been relaxed a little bit as you increased more labor. How do you interpret this one? Decreasing MRTS from point A to B to C to D to E. You can relate this phenomenon to the law of diminishing marginal returns, right? So as you increase the labor input, the marginal contribution of that increased amount of labor should be decreasing, which is represented in the MRTS, right? For instance, from A to B, your hiring labor is increased from 2 to 3. So 50% of increasing in the total labor income. So it is a huge increase in your hiring labor. So there is, if you fix the output at the constant level, then there will be huge sacrifice in the capital, right? Because the contribution of that additional labor will be huge. But from point D to E, you increased from 5th one to 6th one. So the total increase in your labor input is maybe less than 25% of the total labor input. So the marginal contribution of that 6th unit of labor should be small, should be modicum. So it will be represented in the MRTS, which equals to -1 here, which means that there is diminishing marginal returns by the additional increasing in your labor input, and it is represented in the decreasing trend of MRTS. Okay, so we can stop here to finish our third part, and we're gonna finish in the fourth part later of this chapter.